Hello, and welcome to Algebra 2. Our topic for today is solving rationals. And today is Tuesday, October 27th. Okay, before we jump into that first example over there, we're going to start with a little mini example here. So what if we had x over 4 equals 3 over 4? Now, most of you could probably look at this and tell me, oh, x has to be 3. So let's think about why this is. Because when denominators match, I multiply by the denominators, they will both cancel out and we'll be left with x equals 3. Let's look at one more mini example. What if I have x plus 2 over x plus 3 equals 3 over x plus 3? So again, our guiding principle is we want to get denominators to match. Our denominators already match, so we multiply both sides by x plus 3. And we get x plus 2 equals 3 minus the 2, so x is 1. So basically, what I'm trying to say with all this is that when denominators are equal, we should write this on our note, then numerators are also equal because we can just multiply and cancel out the denominators. Okay, pause wherever you need, but we're going to go to our first real example. Okay, great. Make sure that you pause and that you've written out this example. Okay, so we need the denominators to be the same. I see they both have an x minus 2, so this first one just needs an x plus 3. So I've got the first fraction stays the same. Okay, our denominators are equal, therefore our numerators are also equal. And this happens, again, because we can just multiply by the denominators and they'll both cancel out. So then I have 3 equals 3 times x plus 3. We're going to distribute that 3x plus 9 plus 9. Negative 6 equals 3x divided 3. And we have that x is equal to negative 2. All right, let's try another one. Okay. Great. So on my left-hand side here, sorry, this is example 4. Make sure you pause and write it. On our left-hand side here, I can see they both have the same denominator. So I'm just going to take a moment to put that as a single fraction. Let's combine like terms up there. Negative 5 minus 1 is r minus 6 over 3r equals 1 over r. Great. So really your first move is try to get it down to one fraction on each side. So I have 3r on the first one, just a single r on the second one. So if I multiply this by 3 over 3, then they'll be matching. Denominators are the same, therefore numerators are also the same. So I have r minus 6 equals 3, add 6, and r is 9. All right, let's look at another one. Okie dokie. Okay, a lot going on here. Let's handle this right-hand side first. If you pause, write the problem. Let's handle the right-hand side first and see if we can get that to be one fraction. I can rewrite this 1 as n plus 1 over n plus 1 because anything over itself is just 1. Okay, on my right-hand side now, they have matching denominators. So I can put them as a single fraction. So n plus 1 plus 6 over n plus 1. They combine like terms up there. Okay, they both need a term they don't have. This first fraction needs n plus 1, and the second one needs n plus 8. Alright, so then I have n plus 1, n plus 5, n plus 1, n plus 8. Resist the urge to cancel here, because if we canceled those n plus 1s, we would just end up back where we started. Over here, I have n plus 7, n plus 8, over n plus 1, n plus 8. Denominators are the same now, therefore numerators are the same. So we're going to set the numerators equal. Okay, we're going to multiply these in a box here. I'll do that off to the side. So my first one is n plus 1 and n plus 5. This is 1 times 5 in the bottom right. Don't forget to add these together. So I have n squared plus 6n plus 5 equals, let's make another box here. We got n plus 7, n plus 8. Remember, these will add together. So I've got n squared plus 15n plus 56. I'm going to move things over to the right-hand side. So if we take this away, these all cancel. Minus 6n, minus 6n, and then minus 5, minus 5. So now I have 0 equals 15 minus 6 is 9, and 56 minus 5 is 51. Go over the 51. So 9n equals negative 51. And our final answer is n is negative 51 over 9. Okay, we got one last example here. All right, our goal stays the same. We need to get the denominators to be the same. So I've got 1 over 6b squared. So this guy needs another b value to become 6b squared. And then the 1 over b squared needs a 6 to start matching. So I've got 1 over 6b squared plus b over 6b squared equals 6 over 6b squared. Okay, add the two fractions on the left-hand side together. So I've got 1 plus b equals 6 over 6b squared. Okay, denominators are the same, so we can go ahead and set the numerators equal to each other. I've got 1 plus b equals 6. So my final answer is b equals 5. Alrighty, that's all for today, guys. Thanks.